Deep beneath Kentucky's rolling hills lies Mammoth Cave, the world's largest network of natural caves. A labyrinth carved from ancient limestone. For centuries, explorers have wandered its upper chambers, but its deepest passages have remained untouched, preserving secrets older than the dinosaurs. Imagine a team of paleontologists, their headlamps piercing the darkness as they navigate a newly discovered passage, far from any trail. The air is cool and still, every footstep echoing in the immense quiet. They are not just exploring a cave, they're traveling back in time. Suddenly a beam of light reveals something extraordinary, a long serpentine spine and a skull with rows of menacing teeth, embedded high in the rock. The team falls silent, realizing they found a creature from a time when Kentucky was a tropical sea. As their lights scan the walls, more fossils emerge, strange skulls, bizarre jaws, a prehistoric graveyard perfectly preserved. These are not just bones, but the remains of predators that ruled an ancient ocean 325 million years ago. Here, in the deepest silence, the whispers of a vanished era begin to speak. The discovery electrifies the team, banishing all fatigue. They quickly realize this is more than a single fossil. It's a window into a lost world. The cave walls tell a story of life, death, and the immense slow power of the earth. In this darkness, the past is not gone. It's waiting to be found. The journey into the unknown has only just begun. To understand these sea monsters, we must travel back 325 million years to the Carboniferous period. North America was near the equator, submerged beneath a warm, shallow sea, more Caribbean paradise than Kentucky hills. The limestone of Mammoth Cave was formed from the remains of countless marine organisms, layer upon layer, compressed into stone. This cave is a monument built from the bodies of a bygone ecosystem. The ancient sea teemed with giant arthropods, forests of sea lilies and early corals, all thriving in sunlit waters. It was a world of intense competition and evolutionary innovation. The air above was rich in oxygen, fueling giant insects and amphibians on land. In these waters, our sea monsters thrived as apex predators patrolling reefs and open seas. They ruled a world of constant sunshine, warm water, and ever-present danger. They could not have imagined that their remains would one day be lifted into the heart of a continent. The story of their world is written in the very rock beneath our feet. The first predator to emerge from the stone is Dracopristis, the dragon shark. Related to modern sharks, it was long and slender, more eel-like than today's sharks, reaching over 3 meters. Its powerful jaws were lined with needle-like teeth, perfect for seizing slippery prey. Dracopristis was likely an ambush predator, weaving through ancient reefs, camouflaged in the shadows. When prey approached, it lunged with explosive speed. Its victim had little chance. Its jaws gripped and held, ensuring no escape. The fossil is remarkably complete, showing its cartilaginous spine, skull, and formidable dorsal fin spines for defense. These spines warned off larger predators, a clear do not touch in the brutal Carboniferous Sea. Dracopristis was both hunter and survivor, a product of evolutionary arms races. Its discovery reveals the diversity of early sharks. Far from a simple lineage, it was a riot of evolutionary experimentation. The dragon shark is a reminder that the past was filled with unique, now vanished forms. Each fossil is a masterpiece of adaptation to a world long gone. The second discovery is even stranger. Helicoprion, the buzzsaw killer. Famous for its spiral tooth whorl, this jaw structure puzzled scientists for decades. The Mammoth Cave specimen confirms Helicoprion was a large open-water predator, a relative of sharks and rays. Unlike Dracopristis, Helicoprion hunted in the open sea, likely preying on ancient squid and ammonites. Its tooth whorl grew as new teeth formed at the back, pushing older ones into a spiral within the jaw. When it attacked, the spiral teeth sliced and pulled prey into its throat, a gruesome specialized feeding tool. The presence of both predators reveals a complex ecosystem, with each occupying a different niche. The dragon shark ruled the reefs, the buzzsaw killer dominated open waters. These discoveries highlight the stunning variety and specialization of early shark relatives. Helicoprion's jaw stands as one of nature's most audacious inventions. The Carboniferous seas were filled with evolutionary marvels. The journey from ocean floor to cave ceiling spans hundreds of millions of years. When Dracopristis and Helicoprion died, their bodies settled into soft sediment, protected from scavengers. Over time, layers of shells and marine debris buried them, pressure and minerals transforming their remains into stone. This process, called permineralization, preserved their skeletons in exquisite detail. As continents shifted, the ancient sea drained away, and the seabed was uplifted to become dry land. The limestone layers containing the fossils became part of a vast plateau. Rainwater, slightly acidic, seeped into cracks, dissolving the rock and carving out Mammoth Cave. The growing cave system eventually intersected the fossil layer, exposing the sea monsters high on a passage ceiling. Their stone tombs hung in darkness, waiting for rediscovery. Each fossil is a survivor of geological drama, a messenger from a lost world. The cave's walls are a living archive of Earth's deep history. The discovery of two top predators reveals a rich, productive Carboniferous sea. Such predators could only thrive if smaller fish, crustaceans, and cephalopods were abundant. Dracopristis specialized in reefs, Helicoprion hunted open waters, each filled a unique niche. This separation mirrors modern ecosystems, where predators avoid direct competition. These finds challenge the idea that prehistoric life was simple. Carboniferous oceans were dynamic and innovative. Studying these fossils helps us understand the pressures that shaped all sharks and jawed vertebrates. Each discovery raises new questions about evolution's endless experiments. Finding a fossil in a cave ceiling is just the beginning. Today, scientists use non-invasive tools, laser scanners and photogrammetry, to create detailed 3D models of fossils. These digital models allow for study from any angle, preserving every detail without touching the original. Virtual excavation reveals hidden anatomy, even when parts remain in stone. For creatures like Helicoprion, digital modeling solved the mystery of its tooth whorl. Biomechanics brings these fossils to life, simulating movement, bite strength, and swimming speed. Its digital resurrection static bones become dynamic, living beings. This technology enables global collaboration and preserves fossils for future generations. The Mammoth Cave discoveries showcase this new frontier, combining daring exploration with digital analysis. Human curiosity and technology now work together to uncover Earth's deepest secrets. Each fossil is not just a relic, but a story we can now see unfold. The past is more alive than ever before. Bones and teeth reveal much, but scientists hope for more traces of original biological material. DNA is too fragile to survive 325 million years, but proteins like collagen can sometimes persist. The rapid low-oxygen burial in Mammoth Cave may have preserved these molecular echoes. Using mass spectrometry, researchers search for protein fragments, a direct chemical link to ancient life. Such a find would revolutionize our understanding, clarifying evolutionary relationships and physiology. It's like finding a hidden manuscript written in biology's own language. The search is meticulous, but the reward could be enormous. In the cool, stable darkness of Mammoth Cave, the quest for ancient chemistry continues. The discovery of these predators reminds us that Earth still holds profound mysteries. Mammoth Cave has over 400 miles of mapped passages, with many more unexplored. Each new tunnel could reveal another window into the deep past, perhaps even larger predators or the first amphibians. The cave is a vast, three-dimensional library, and we've only read the first pages. These fossils reshape our understanding of the world, connecting us to a past almost beyond comprehension. Landscapes change, continents drift, and oceans vanish. Earth's history is dramatic and ever-changing. Exploring hidden corners is a journey of self-discovery, revealing the processes that shaped all life. Dracopristis and Helicoprion are more than curiosities, they are messengers from a lost time. As long as there are caves to explore, the adventure of discovery will continue, showing us that our planet's story is even more wonderful and stranger than we ever imagined.